Welcome back to the unit on transformations. In today's lesson, you will learn about a type of transformation called dilation and about similarity. Today's goals are that you will know how to use a center of dilation and a scale factor to describe a dilation and also to transform a figure using a dilation. And you will be able to explain how a dilation affects the size of the image. So in our first example here, we're going to transform QRS by dilation with a center of dilation T and a scale factor of 3. And a center of dilation T means we'll start at T and we'll measure the distance from T to each of these points and multiply that distance by 3 to find the new point. The point on the image. So from T to Q is a distance across 3 boxes diagonally. We can calculate it by going up 1 and 3 to the right. So let's multiply that by 3. Instead of going up 1, we'd go up 3. And instead of going 3 to the right, we would go 3 times 3, which is 9 to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. So Q prime will be here. And for R, we will go, to get from T to R, you would go down 1 and 4 to the right. So multiplying 1 and 4 by 3, we would go down 3 and 12 to the right. Over here, this is R prime. And then for S, to get from T to S, we go down 2 and to the right 2. So multiplying those by 3, we will go down 6 and to the right 6. And this is S prime. And now we can draw our image. If you're doing this on graph paper, you would use a ruler and get a very accurate drawing. I'm doing it on an iPad. So we can see here that Q prime, R prime, S prime is much larger. It's not congruent to QRS, it's much larger. And that's because the scale factor is 3. We're multiplying all side lengths by 3. And so when our scale factor is greater than 1, the image is larger than the pre-image. The shape stays the same. They're similar figures, but one is larger than the other. So we just saw where a scale factor greater than 1 creates a larger image. In this example, we have a scale factor of less than 1, so we should be expecting a smaller image because the scale factor is only 1/2. And the center of dilation is the first thing we need, and that's at the origin, which is where the X and Y-axis intercept. So we'll measure from here to the points A, B, C, and D and get half of each of those distances to draw the image. So from the origin to C is up 4 and to the left 2. So dividing both of those numbers in by 2, because it's a half, we'll go up 2 and over 1 to get C prime. To get B prime, B is 6 units up and 2 units to the left. So dividing that by 2, we'll go 3 units up and 1 to the left. Here's B prime. A is 6 units up and 6 to the left. So dividing that by 2, it'll be 3 units up and 3 to the left. That's A prime. And then finally D is 2 units up and 6 to the left. So to get the image, dividing by 2, we'll go 1 up and 3 to the left. So here we are, is D prime. And now we can join these to draw our image. And we can see that the side lengths of A prime, B prime, C prime, D prime are all half the side lengths of A, B, C, D. The scale factor of 1/2 has created this image with side lengths that are half the size of the original image. So it's smaller, the image is smaller, and it's very similar otherwise. The shape is the same, the angle measures are the same. So it's similar. We can also have a dilation from within a figure, not through an external center of dilation. So in this example here, the center of dilation is at P, which is in the middle of the rectangle, and with a scale factor of 2, 2 is greater than 1, so the image should be larger, and it is. We can see A prime, B prime, C prime, D prime, which I've already drawn, is much bigger than A, B, C, D. And if we compare the side lengths, A prime, B prime is 2, 4, 6, 8, 10, 12 units long, and AB is 6 units long. So a scale factor of 2 means that the sides of the image are 2 times longer than on the pre-image. And that is the case all around the 4 sides of the image and the pre-image. So looking at similarity, we need to either know the side lengths or the angle measurements, or both. So let's look at this example here. On the left hand side, we've got a figure with sides that are all 2 units long, and on the right hand side we've got another figure with the side lengths that are all 2 units long. Even though the side lengths are congruent, the angle measures are different, and so these figures are not similar. The angle measures must be the same for the figures to be similar. So no, they are not similar. And looking at these triangles, it's not as clear, because they're oriented differently. But if we match up the corresponding angles and then compare the angle measurements, we can see that the corresponding angle measurements are congruent, and so yes, these two triangles are similar. And we could also take those same two triangles and transform one of them, ABC, so that it's moved into DEF, we can see here on the right hand side, and then is dilated to be, can be dilated to be larger, to be the same size as DEF, and we can see then that they are similar. Equivalent ratios indicate that figures are similar. This is useful for when we don't have angle measurements, but we have side measurements. So let's look at equivalent ratios of sides here. So on the original figure, AC over AB is 3/5. That's a ratio. And let's look at the corresponding sides on the image. That's 6/10. Are these equivalent ratios? So if we have 3/5 and multiply it by 2/2, we get 6/10. So yes, they are equivalent ratios. And if we want to choose another pair, for example, of lines, say CB over AB compared with C prime B prime over A prime B prime, we get 4/5. Is that equivalent to 8/10? If we divide 8 and 10 by 2, we get 4/5. So yes, they are equivalent. And so yes, they are similar. So to summarize, a dilation creates a figure which is similar to the original figure. The angle measures must be congruent, and the side lengths, the ratios of the side lengths must be equivalent. And the side lengths will be different. They won't be congruent unless the scale factor is 1. If you're multiplying the side lengths by 1, they're unchanged, and so then you will have congruent figures. But usually the scale factor is greater or less than 1. So to summarise or to recall today's goals, you can now use a centre and a scale factor to describe a dilation. You can transform a figure by dilation, and you can explain the effect of the dilation on the size of the image. And that's the end of today's lesson.